Fully homomorphic encryption fee with tenseal in Python. Fully homomorphic encryption fee allows computations to be performed on encrypted data without needing to decrypt it first. This means that sensitive data can be processed securely, supporting privacy-preserving applications. Overview of tenseal. Tenseal, a library for performing fee in Python built on top of Microsoft's Seal Simple Encrypted Arithmetic library. It focuses on enabling machine learning and data science operations on encrypted data. Prerequisites before you can use tenseal. Ensure you have the following installed: Python 3.6 or later pip Python package installer. Installation: you can install tenseal using pip bash pip install tenseal. Basic concepts of tenseal. 1. Context defines the encryption parameters. Tensor represents encrypted data, similar to a NumPy array. Homomorphic operations supports operations like addition and multiplication on encrypted data. Example: encrypted addition and multiplication. Let's walk through an example that demonstrates how to use tenseal for basic homomorphic operations. Step 1. Import libraries. Python import tenseal asks a step to create encryption context. You need to set the encryption parameters, including the polynomial degree and the coefficient modulo size. Step 3. Decrypt. Set decrypt sected decrypt set 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 theory protocol set decrypt theory curve third theo separative 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 Scheme technique 8190. 40 step to create vectors vector run 1.0 2.0 2 point peggy headward pay a rate point take a point Pipeline Victor point to point baker to point you to port baker to port per view per taker to put Sager to Sapical quote Sapical Sacred Bacred Sabu to Sapical to rear poem Therapeutic people real POM substitute to pill substitutorial substitute to therapeutic substitute therapeutic pill substitute to give to therapeutic to Precision Hook's scheme supports approximate arithmetic, so results may not be exact due to rounding errors. Performance homomorphic operations are computationally intensive, so expect slower performance compared to operations on unencrypted data. Use cases tenseal can be used in applications like privacy-preserving machine learning, secure data sharing, and more. Conclusion tenseal provides an accessible way to work with fully homomorphic encryption in Python. The example above demonstrates fundamental operations, but tenseal supports more complex operations and data structures. As you explore further, consider diving into the documentation for advanced features and optimizations. References tenseal documentation HUTS tenseal read the docs, yo in latest Microsoft Seal at GitHub Microsoft Seal. Feel free to reach out if you have any questions or need further assistance.